Okay, so here are the two topics I'm going to be talking about this week, the research process and the quality of research. I think I'm going to talk first of all about the quality of research, issues to do with that, and then I'll talk about the research process itself probably in the second half, that way around. I think that's how the slides go. I'm going to start by talking about a rather ancient book now. I just realised when I looked at this the other night, 1988, Shipman. I think it's still being published, it's still around. But he, I think, makes the nice point about there being four major questions about the quality of research. And essentially the questions are to do with how can we be sure that the research that's being discussed or talked about or in the published paper or whatever, how can we be sure that that is good quality research? What makes it good quality research as opposed to rubbish research? And of course that's an important point going back to what I said last week, that research design, which is what I've been talking about in a lot of these sessions, is to do with collecting information about the world in some kind of structured and socially approved manner. So what makes it socially approved is these criteria I'm going to be talking about this week of good quality. How can we distinguish just simply looking at something and saying something about something and proper social research? So these are the four key questions. I'll go through each of them in turn and talk about and discuss each of them. I think the other important point to bear in mind about them is that they relate to your assessments. The article you'll be reviewing for the assessment, the questions you have to ask about that are to a large extent to do with the quality of the research in there. I'm not really, as I said last week, I'm not really interested in whether it's a good piece of research in the theoretical area it's discussing, but what I am concerned with is how they collected the data, how well they did that, how they analysed the data and what they made of it when they wrote the thing up. So these are the four questions. The first one then, number one, is if the investigation had been carried out again by different researchers using the same methods, would they have got the same results? Would the same results have obtained? So in a different circumstance, done by different people, would the results still be the same kind of results as before? And that criterion is called reliability. Is the research reliable? So in other words, if we repeat it, did we reliably get the same answers as we got before? If we don't, if something happens and goes wrong, then we say it's unreliable, the research. And it's important to recognise that that's different from other criteria, which I'll mention in just a moment. Something can be perfectly valid as a piece of research. It can be doing the right things, but it can be unreliable if it gives different answers each time. Now, how can that come about? How can we get different answers? Well, here's some suggestions at the bottom, three different ways that can happen. What's called subject error, the first of those, the idea of getting different results on different days. And I have to say that's a very common feature of a lot of research, particularly qualitative research. In fact, you almost expect to get it in qualitative research. The kind of research where you're doing, say, observations of people or depth interviews of people in a kind of qualitative fashion, that you almost expect people to act differently on different days. Nobody, when they're asked a question, says exactly the same thing one day to the next day. They will say it slightly differently. So you do expect some variation. Now, of course, in qualitative research, we adjust for that by not sort of spending too much time dwelling on the actual things they said, the way they said it, and so on, but rather what they talked about in a general sense. But other subject areas perhaps are more important. That they may, change the results in significant fashions, not because anything has actually changed in the world, but just simply because people do change from day to day in that kind of fashion. So you have to be very aware about that. A lot of social sciences gets around it by looking at things that actually don't change that much, or things that people aren't aware of and do automatically. But other things where there's lots of variation, the kind of things where nothing's terrible, where a thing isn't terribly important to you, for example, and you just simply come up with some kind of view about it. Well, of course, it's going to change from day to day. That's called subject error. Subject bias is where the results are changed because the people you're doing the research on, the participants or the subjects of your research, actually change their answers to match up with whoever's doing the research. So maybe they like one researcher and don't like the other one. And so the answers they give are different to the two different researchers because they like one and dislike the other, for example, very, very simply put. So the bias comes in by the fact that the answers are given differently to different researchers, and therefore, of course, if you repeat the research with different researchers, you're going to get different results. And we have to try very hard to get round that in research. When we're doing research, one of the things you have to bear in mind is not to encourage that kind of subject bias, not to encourage people to give the answers that we might expect or to act in different ways to us because it's us rather than somebody else. I mean, and it's a very fine balance. You have to be a good researcher, you have to be, get on well with your research participants, you have to, not mistreat them and so on. But on the other hand, you mustn't get too pally with them so that they, in a sense, change their answers because it's you. And lastly, there's a crucial one for lots of experimental designs. I mean, if you've done a psychology course, you might well have done this in your first year. You run an experiment in which you create observer bias. The point here really is that the researcher, who's the observer, the researcher sees things differently because they expect certain kinds of results. And there are some classic experiments done in psychology where you can actually force the researchers to give certain kinds of answers because that's what they expect to see when they're looking at the results of the experiment or whatever, or looking at the experiment going on. So in this case, it's nothing to do with the participants, it's to do with the researchers themselves having biases that mislead them. And of course, different researchers on different occasions might have different biases, and therefore the results are unreliable for that reason. So reliability is the first criterion then of good research. Good research is consistent from occasion to occasion, from researcher to researcher, and so on. And we can be sure that if we redo it, other things being equal, we're going to get the same kinds of answers. So that's reliable research. Okay, the second question Shipman asks about research is this one. Does the evidence reflect the reality under investigation? Or, put it another way, has the researcher found out what he or she thinks it's actually about? Is it a true reflection, if you like, of what's actually going on? And that's called validity, or sometimes referred to as internal validity. The two terms are used interchangeably. I say internal, but there is an external, which I'll talk about in just a moment, so bear that in mind. But if you see validity just used by itself, it means this. And essentially, I mean, now one point to bear in mind, I'll come back to this in just a moment, one point to bear in mind here is this notion of reality. In this concept of quality, we have to take on trust that there is some kind of situation out there in the world which we're trying to measure or trying to capture or observe or something in some way find out about, that it exists there independently of us. It's a real world idea and it's a real world that's out there that we're trying to capture. The question then is, the results that we've got from our research, do they in some way match up to that reality? Are they a true record of what's actually really going on or not? Now, there are some people, there are some researchers, some social scientists, some philosophers for that matter, who disagree with that fundamental view that there is a real world out there independently of us. The constructivists, for example, would argue quite differently and say that the world is created by us, the world we see, the world we experience. I'll come back to that argument in just a moment when I talk about qualitative research. To give some examples of this, I've got a handout. Now this is taken from Cook and Campbell. I'll come back to them in another session actually. I'm going to be talking about experimental designs and particularly quasi-experiments. And they've written a lot about that, and this was in that context. So it's worth hanging on to this and bringing it to the lecture on experiments when I talk about that in a few weeks. But for the moment, what they've done here is give a list of the kind of things that can go wrong in an experiment which threaten validity. Ways in which you get results in which you think you found what's actually happening, but you haven't. Or the researcher thinks they've got something, but something else has caused the situation that you've actually got. It's not the true reflection of reality, it's in some way biased or inaccurate. So, just for example, number one on the list, and I won't go through all of these, and I'll leave you to read some, but I'll pick out perhaps some of the highlights. Number one, the history threat. Something in the history of the situation has changed things so that the picture you as a researcher get is not accurate. It's not a real picture of things. So things have changed in the environment other than those forming a direct part of the inquiry. And the example I give here in brackets is the occurrence of a major air disaster during a study of the effectiveness of a desensitization program on people with fear of air travel. So you've set up some kind of experiment where you're trying to work out whether your program of desensitization, maybe it's a talking program, or maybe it's a program of going up to aircraft and touching them and things like this to desensitize people to the whole idea of air travel. Whatever you're doing, in the middle of that, suddenly there's an enormous air crash and it's all across the newspapers, on the TV and so on. Now, of course, that's going to raise the anxiety amongst the people that you're using in your sample to test your therapy program. So it's going to have that effect. Thanks very much. It's going to have that effect of raising anxiety and therefore appearing to show that your program of desensitization doesn't work. So it looks like your research shows the program's not very effective, but in fact it's because of this exterior event, this history event, something in the environment that's changed, in this case having an air crash in the middle of that program. If you reran it sometime later when there wasn't an air crash, you might find quite different results. So the results you get don't reflect the reality, but rather something else. Okay, let's look at number two, the testing effect. And this is where some kind of change occurs as a result of the practice and experience gained by actually doing the research, by taking part in some kind of research, the pre-test, for example. So here it's, the example I've given in brackets is asking people about their opinions of factory farming of animals before an intervention might lead them to think about the issues and develop more negative attitudes. So that you've got some kind of research program looking at what people feel about factory farming, but simply raising the questions. It's not a subject that people often think about, perhaps, or at least most people don't think about a lot. You just go in the supermarket and buy your food, and that's it. Don't raise questions. So actually raising the questions explicitly before the research in some kind of pre-test that you might do begins to bias people. They start to think about what a factory farm is and what it does to animals and so on in ways that they wouldn't normally think. And so what you then get is people who are in some way sensitized to those issues in your research, and I suspect therefore more likely to be against the idea or worried about factory farming and so on than they would otherwise be in other senses. So there's something here about the pre-testing, the setting up of things. And as I said in the brackets here, this is a very common problem in questionnaires. You have to watch this when you're designing questionnaires, that by raising issues earlier on in the questionnaire, you might tend to start making people think differently about it when they answer questions later on in the questionnaire. So in the design of questionnaires, you have to be very aware of this kind of raising issues in ways that are going to bias later answers. That's another problem with validity, in a sense. You're finding an effect that isn't the real thing, but rather something that's been pushed by your questioning or your question order.
I'm struggling a bit with that concept.
Okay, yeah.
What if you're asking a question of somebody and it prompts them to think they don't like farming, factory farming? Surely then that is what they think about it. That's what I'm struggling to get my head around.
Yeah, it is. I mean, I have to say, in a sense, there's another concept here. What is the normal process, if you like? But you could, you're quite right. You could argue that having raised the issue, that of course that's what they think, because having raised the issue, and if the issue were being raised all the time normally, that's what people would think about it. But if the issue weren't raised in that way, if they weren't prompted to think about it, they just simply ask questions. For example, imagine you had a pre-test that was focusing on factory farming, and then later on you had questions about, when you're in the supermarket, do you worry about how the animals are treated and so on, okay? Well, they might answer yes, because they've suddenly thought about it later on. But actually, normally, when they're in a supermarket, they wouldn't be doing that. So you've got this idea of how people would normally act outside the research context. But the biasing is introduced by this question early on and makes them answer differently about what they really are. So you've got a bias in their answers.
What about when you want to repeat your survey then? Because, like you've just said, it changes people's views because it forces people to think about it. So if you come back then the following year and you have a cohort of people that you're surveying happens to have partly the same people, maybe.
Yeah, it is a common problem. I mean, a year later probably isn't so much of an issue because it's enough time to forget what happened in the previous thing and so on. But if it's a closer time period, it can be a real problem. There's a very nice example I came across. I can't remember where I read this now, but it was years and years ago. I remember when I was a PhD student, I bought a book about how to read faster. This idea of, I don't know if you've come across this idea of speed reading, that you can not control your eyes, so you just look at the middle of the text and read a whole page and get the comprehension of it very quickly. Now, this was an experiment, or rather a test done, to see whether a course in reading quickly really worked or not. And what they had was a design with a pre-test and a post-test. So before the course, they did a test on people, they did the course, and then they did a test afterwards to see if they'd actually improved their comprehension, their reading speed. The test before was to get a passage, read it as quickly as you can, and then answer questions about it. And then the test afterwards was to take the same passage and read it quickly and then answer questions about it, the same questions. Now you can see the problem coming up here, that yes, in one sense, nice design because the measure is the same, both before and after, doing exactly the same things, that's what you want. But it was only a few hours apart. So of course they would remember the passage they'd read the second time they read it. So you've got that kind of that bias again coming out because they've remembered what's going on. So you've changed the way they're going to answer, even if they hadn't had the course in the middle. And of course what you get in this case is an over-optimistic or an over-positive set of results, because people do the job very well, partly because they've done the course probably, but also because they read the passage that morning and can therefore still remember some of it to answer the questions.
Could you also argue in that scenario that they might always have been very good at reading quickly, but they've never tested themselves doing it? So,
well, that's why you have the before and after. That deals with that problem. Doing it before, you get a range of people, some who are good, some who are bad, and you hope that everyone's improved at the end. Maybe the good people have improved slightly less than the other people, but you hope it's made some difference. So that's why you have the before test to get rid. Otherwise, you're dead right, that would be a problem. You didn't have a test beforehand. Who knows what you're going to get afterwards, yeah. That's all very relevant to the exercise you'll be doing. So bear in mind those examples, because that'll come up in the exercise we'll look at later on. Okay, let's get on to number 3 then, instrumentation problems. It's odd in the social sciences, it's odd to talk about instruments, but we talk about things like a questionnaire as an instrument in social sciences. So some way, some aspect of the way that participants are measured has changed between pre and post tests. So an example given here is a rate as an observational study using a wider or narrower definition of a particular behaviour. So again, in this case, it's probably a problem of training and problem of consistency in the research themselves. That there's a shift in the way people are using the criteria they're applying to observe things or measure things. And you have to be careful about that. In that case, of course, the differences you find will be because of the different ways in which the researchers are doing their work rather than any real differences in the way people themselves are acting. And then there's a regression effect, which is a very common one, actually. It comes up in all kinds of ways. I'll mention why it came up fairly recently in just a moment. But let me explain first of all what it is. In regression problems, the participants are chosen because they are unusual or atypical. For example, high scorers in some kind of educational test. And later testing of those same people would tend to give less unusual scores. It's called regression to the mean. That if you score high scorers, then when you score them again later on, their results will tend to be less extreme and more towards the mean, if you like, of the population. And of course, the same way the other way around. Take very low scorers and test them again, they'll tend to score better the second time around because they've moved towards the mean on average. Let me just, as an aside, why does that happen? It happens because the actual score somebody gets, say it's an educational test or a reading test of some kind, the actual score they get is a combination of two factors. One is, in a sense, how good they are, and that's the result of their previous experience and whatever testing, whatever experiment you've done with them and so on. So it's a measure of how good they are, plus a random factor of anything else that might change. Did they wake up feeling fresh that morning? Have they got a headache? Has it been a bad day on getting into work and so on? All those kind of things that affect how well you do on a test. The next time you take the test, those factors would have changed. Those other random factors will be different. It might be a good day for you that day. You've had a good night's sleep and so on and so forth, and you feel much more on top of things. So a certain proportion of your score will be improved for those reasons. The underlying score, which is reflecting your ability in a sense, stays the same or across the two tests. So we've always got that problem. Of course, when you pick the highest scorers, you've picked the people not only who are good at something, but also had a good day that day, woke up and had a good night's sleep and so on, and had a good journey in on the bus that morning, etc. And the ones at the bottom end are the ones the other way around. So when you retest them, they're likely not to have had those other extra circumstances the same, and therefore they regress to the mean. So you have to be very careful about that if you're choosing people in that way, because you'll find results because of regression rather than because of any actual real change in their scores. The example I give here is an intervention program with pupils with learning difficulties, where you pick the 10 highest scoring pupils matched with the 10 lowest scoring pupils. And then if you retest them, of course you're going to get these regression effects. The 10 highest scoring will tend to regress the mean downwards, and the 10 lowest scoring will tend to go the other way. The 10 next time round will tend to raise the marks towards the mean. Not because of any change in their actual ability or whatever, but simply because of regression to the mean. The way that came up recently was there's the National Student Survey that asks you your views about the courses and so on. And one thing that happens is once the universities get that, we get breakdown by courses and so on. And each course gets said, or gets told that you've done very well or you've done very badly or whatever. And there was one unfortunate course in this university that had done very well one year, and I think they'd come top or nearly at the top. The next year, they didn't. And they came, 10 places down. And it's quite a small course as well, a small number of students on it, perhaps a dozen or so. Nobody realised in the hierarchy here, everyone got criticised for dropping down. You've dropped 10 places, from the top down to number 10. But of course, that's regression to the mean. They got to the top from a combination of good students who enjoy the course and so on, good teachers, and they had, sunshine in the classes and all sorts of other things that went well that year, etc. The next year, same students, same good staff, etc. But perhaps it was raining all the time and people didn't feel so good about things, so the marks dropped a bit. Who knows? But you get regression to the mean in that way. So you have to be very careful not to judge things too quickly if that might be a problem. And it's often a problem when you're talking about the other thing is Olympic scores, there's Olympic results. Someone does really well one time in a race, are they going to win it the next time? Well, of course, they're a very good runner, so they have a good chance, but they might not. Somebody else might just pit them to it because they're having a good day that day. And that's regression to the mean. Okay, let me pick out one or two others here. I'm going to pop down to number 11, compensatory equalization. This is a problem that often occurs when you're working, doing research in organisations, things like hospitals and so on, which is the example I've got here. One group receives a special treatment, and there's often organisational pressures or even professional pressures for the control groups to get the same. And what you actually want to do here is have one group that's getting the treatment, so you're doing something with them, you've changed something with that group, and the other group doesn't get it. They're the norm. Nothing particularly special happens to them at all. That's how you really want it to happen. But what often happens is that the professionals working in the organisation say, well, actually, they're doing so-and-so with that group. Perhaps we ought to do something similar, or we ought to spend a bit more time with our patients or our clients or whatever, so that so-and-so happens. So that they know about what's happening with the other group, and they try to adjust for it. And of course, the result of that, very often, is you find no difference, when you should be finding a difference. And the reason there's no difference is because people actually acted differently with the control group because of that. That's called compensatory equalization. So the professionals trying to compensate. Here's the example: nurses in a hospital study improve the treatment on the control group on the grounds of fairness. Of course, that's quite right. If they know it could be done better, then they should. And it's very hard to control for that. Another example of the same kind of thing is number 12, compensatory rivalry. But in this case, it's not the the professionals, if you like, but rather the participants themselves who act differently. And I like it because it's referred to as a John Henry effect, after this steel worker, I think he was in the States, who killed himself through overexertion. He was trying to prove that he was better than a new steam drill that they introduced into the factory. You know, oh, I don't need a steam drill, I can do it better. And he worked so hard, he exhausted himself and killed himself to try to compensate. And that's the kind of thing that happens in research, that people realise that, you know, someone else has got something in the study that they haven't got, and they try to make up for it in some way by doing something different or working harder. So that the control group in some way reacts to work differently to make up for the fact that they've not got the, I don't know, say you've got two departments and one department have got new computers and the other group haven't. Well, the group that haven't got new computers in some way make up for it by acting differently, working harder or doing better things with their computers or whatever, to make up for the fact that the other group got new stuff. And of course, again, the net result of that kind of bias is to minimise differences that you should be finding. Okay, so all of those then are threats to validity. That's the Cook and Campbell list. And what they're saying effectively is that the results you get are not the real results. And of course, that's the important point to bear in mind here, the difference between reliability and validity. And one way of thinking about this, just as a kind of metaphor, is to think about it as a kind of well, I suppose the metaphor is shooting arrows at a target. You know, an archery target has got rings around it and a bullseye in the middle, the centre bit that you're aiming for. You're trying to get, that's the highest score in the middle, and you've got rings around it. Well, reliability, a poorly reliable or an unreliable archer, what do? They just shoot all over the place. The arrows go anywhere. You can't tell where they're going to go. They're just unreliable. They might hit the middle, they might not hit the middle, and so on. An archer who's not valid might be very, very good. You know, a valid researcher hits the bullseye all the time. You know, they're very good at it. They're very, you know, they're hitting the right thing, etc. An invalid one might be equally accurate, but off to one side. So they're not hitting the bullseye, but they're hitting somewhere out, you know, a few, you know, inches away or a few centimetres away. They're very accurate at getting there. All the arrows hit that one single place, but it's not the bullseye. That's what we mean by not valid. They're missing. It might be reliable in the sense of they're doing it reliably, they're getting the same thing all the time, but it's not actually a valid result. So that's one metaphor of thinking about the difference between reliable and valid. Okay, let's move on to number 3. Number 3 question that Shipman asks is what relevance the results have beyond the situation investigated? So, I mean, typically in social sciences, we're not looking at the whole society, we're looking at some small group we're working on. That's what makes it practical. An experimental group or a subset or a sample or something of that kind that we're looking at. But we actually want to say something more generally about the whole of society or the whole of that group in some way. And that's called generalizability. We want to generalize from our research group, our sample, to the whole population or the whole of that kind of people. It might not be every single person. It might just be we want to look at, I don't know, students, for example, as a subset of the population, but we might sample a few students and then we generalise to all students. And we might want to look at, I don't know, conservative voters in our study, and we generalise to all conservative voters, but not all people. But there is this sense of going from our sample group to the whole group. And again, we can have threats to that, things that can go wrong with our study that mean we think we've got something that's typical, but we haven't got something that's typical. In some way, what we've actually got is untypical, and therefore we cannot reasonably generalise to a wider population. And here's some examples of that. We can have a selection problem, and this is probably the most typical thing that goes wrong here, a selection problem. The group we've got, the group we're looking at, that we're doing our research on, has been selected in such a way that they're not typical of the general population. Now, I'll come back to this later on in the session on surveys and sampling, because actually the whole procedures of sampling for surveys particularly is one that tries to get around this problem. There are definitely techniques you can use to make sure that the sample you get is representative, can be generalised to the population. But very often that isn't the case. And one common way in which you get a sample that isn't atypical, isn't generalisable, is by getting volunteers. If you just simply say, I'd like people to volunteer to do this, then the chances are that the volunteers you get are not typical. Why aren't they typical? Because they're volunteers. They're the generous kind of people who've got time to spare and who want to get involved and so on. And of course, they are just one subgroup in that. And particularly if your research is related in some way to that issue of volunteering or giving their time and so on, then you're going to find differences. Let's say your research is about how secretive people are. Then I suspect the volunteers are not going to be typical. The volunteers know it's about, well, the people you're asking know it's going to be about secrecy and secretiveness. And of course, if they're very secretive, they won't volunteer. So you've immediately got a bias in your results towards the less secretive people.
I guess would a problem there also be if it was something quite sensitive or quite something about racism or sexism?
Oh yeah, of course.
Now you get people who've got an axe grandeur who are very extremist, might you, that want to...
Yeah. Well, in fact, you might get both, really. You might get two extremes. That's another interesting example. So you get a kind of a balance in your sample, but rather than a balance in the middle, you get extremes. Of you get the really kind of racist people at one end, and the really kind of I don't know what the opposite is, the unracist people at the other end, etc. And you don't get the middle range kind of thing, and so on. So yes, you can get that too. And again, that's not typical of the population, so it's going to be biased in that way. Yeah. So it's and I think it's worth bearing that in mind, that volunteers can be biased. Now, we can't always get round that. I mean, a lot of research relies on getting volunteers. A lot of qualitative research, for example, is done in areas where you can't do random sampling, all this kind of stuff. You have to take volunteers. A very common method of getting samples is what's called snowball sampling, where it's kind of a metaphor here, a bit like when you roll a snowball, it gathers more snow as you roll it down the hill and gets bigger and bigger and bigger. The same way your sample, what you do is you ask one or two people you know who fit in with what you need. And then because they are that kind of person, they know other people like that. And then you ask them for their friends and their colleagues and so on, and include them and so on, because they meet the criteria. So you're snowball sampling. But of course, that again is volunteers, and there are all kinds of problems there with making sure that is a generalizable, a kind of a typical sample of people. But in those kind of cases, that's probably all you can do. It's very hard to get volunteers otherwise. Other kinds of problems can come here. The setting, it might be that where you're doing the research is in some way untypical. You've got you picked a village or something like that at random, but actually what's happened in that village is very different from what happened elsewhere, and so it's not typical. So you perhaps use some kind of random techniques to pick your sample, but in fact, unluckily, you've picked something where something odd has happened. There's quite a nice example I came across years ago when I was studying anthropology here, of just this kind of problem of setting. Actually, it was a problem of both setting and of history. This particular village had had a particular past experience that biased their results as well. And of course, that's another more general issue. That might be the sample you're looking at is different inside because they've experienced something in the past. In this case, it was both the setting and the history that changed. It was anthropologists working in Mexico, and for many years there'd been this idea of what anthropologists call resistance to change. The idea was that there was something in peasant culture that prevented them from developing, and it was some kind of innate conservatism, what they called a resistance to change. They didn't want to change their methods and bring in the new agricultural techniques and try out new approaches and new crops and new varieties and this kind of stuff. They were very, very conservative with a small c. Another anthropologist went back to the same area that had been studied, where this first theory was developed, and realised that actually what had happened was the original anthropologists had gone to a particular village and done this research. In that village, there'd been a history of repression of the peasants. The local landowners, in cahoots with the police, had made sure that the peasants didn't do anything that didn't change anything at all, that they weren't allowed to set up organisations and bring in new crops and so on and so forth. Every time they tried to change anything, the police were brought in and arrested them, and they were taken away and to prison and so on. So their history was one of that kind of repression, of landlords being in cahoots with the police. And so therefore they were quite resistant to any kind of change, quite understandably when you think about it. Of course they didn't want to change. They knew what the risk there was in changing. The researcher who came the second time went to a different village nearby, about 10 miles away, and found something quite different. He found in this other village that they were actually quite innovative, and they'd set up local organisations, they had a cooperative going, and they got some kind of method of buying and selling the crops, and they'd made money, and they got refrigeration units and stuff like that for their crops, etc. So they were getting on quite well, and that was because they didn't have that history of the landlords. In fact, partly it was because they owned their own land, they didn't have landlords. So here we've got a combination of both the setting, the different village being different, and the history, which in this case jeopardised the ability to generalise from one village to all peasants. So the idea that all peasants were like that was quite wrong. It was only some peasants in a quite understandable situation that were doing that. And you might even say it goes on to the fourth one, the construct effect, where this is the idea that only certain groups thinking certain kinds of ways. And again, you have to be careful of that. It may be quite subtle, the different ways people are thinking. And you could say the villagers maybe are thinking in certain kinds of ways as well. So it's a combination of all of these kind of things. But constructs can be quite hard to know about before you've done the research. You're not quite sure why that group thinks differently from that, but they are, for some reason, thinking differently from the others, and they're not typical. So all of these threats then amount to the fact that the group you're looking at is not typical in some important way of the general population, and therefore you're getting a bias in your results. So generalizability is a sign of good quality work, then good quality research is generalizable, and poor work is not generalizable. There's some threat to it. Number 4 is the idea that the work is credible. And as Shipman puts it, is there sufficient detail in the way the evidence was produced for the credibility of the work to be assessed? And this is a particularly important point when you're reading research papers, when you're looking at the results and reports on people's research. You want to know that, okay, they may, in terms of what they say, it may look good, it may be generalizable, and it might be valid, and it might be reliable, and so on. But is it credible? And then you read that these people have never been to university, have never studied social sciences, and in fact, they have no experience of working in this field at all. They've just come into it from nowhere. And you begin to wonder, is it credible? So credibility looks at the way people have carried out the research, their background, their expertise, and so on, and it allows you to make judgments about that. The way they write it up as well, of course. Where they're publishing it, who else has looked at it, who's been involved in the research, who paid for the research. That's a very important factor these days in lots of medical research. Perhaps the first question you should ask is, who paid for the research? Was it the drug companies? In which case you immediately have a question mark against it. It might not be a problem, but we know that it may be a problem if the drug companies are subsidising work. So all of these are issues to do with how credible the work is. Who did it? Their expertise, who paid for it, why they paid for it, and so on, are questions you have to ask about the research. Okay, so that's Shipman's 4 criteria, 4 very important issues about how we judge the quality of research. Is it reliable? Does it give us consistent results across time? Is it valid? Does it actually measure what we think it's measuring? Is it generalizable? Can we work? Is it typical? Can we go from our group to a wider population? And is it credible? Does it make sense? And is there anything dodgy about it, if you like to put it that way?